Dear learners, I welcome you to this module which will help you to understand LB plot, which always comes after equation. LB plot is Lenovo-Burke plot. In a very simple way, it is also called as double reciprocal plot. It is a double reciprocal of Michaelis-Menten equation. The Michaelis-Menten equation ends at a point where we get this equation. As you can see, this is the equation which is the last derivation of Michaelis-Menten equation. We have seen in the last lecture that we had ended up with this equation where the Michaelis-Menten equation forms a relationship between the initial velocity, the maximum velocity, the substrate concentration and a constant which is dependent upon rates of forward and backward reactions. So you have understood that only these three parameters are related in a Michaelis-Menten equation. Now we come to the reciprocal plot. The reciprocal plot is nothing but the left hand side is reciprocated, that is 1 by V, and the right hand side is reciprocated, that is 1 by S, as given in the figure of Michaelis-Menten equation. Now the reciprocal which we have done of the left hand side, it has come to 1 upon V0, and on the right hand side of the equation it was KMS, and that has been separated, the numerator has been separated. So now it becomes Km upon Vmax substrate plus substrate concentration upon Vmax substrate concentration. Okay, so let us give it a number. This is your second number. The first number was the original equation, right? So this is the second number, and what we have done, we have just separated the numerator in the equation. Okay, after simplification of the second equation, here you get, this is the third equation, and in third equation what has been done, the substrate over here has been cancelled. Got it? 1 multiplied by substrate and Vmax multiplied by substrate was cancelled, and finally you derive at this equation. So this equation 3 is nothing but a relationship between LB plot and equation. And how we have gone to LB plot, how we have got the equation? By just reciprocating the values of Michaelis-Menten equation. Okay, so it is actually a plot between 1 upon velocity and 1 upon substrate. Okay, let us go to the figure. This is the figure. If you can recall the lecture of equation, there we had here you had a substrate concentration on the x-axis, and here you had the initial velocity on the y-axis. Okay, now in LB plot what has been done, substrate is reciprocated. Reciprocal means 1 upon S, and V0 initial velocity is also reciprocated, 1 upon V0. The units are the same as they were in case of Michaelis-Menten equation, and therefore you find a plot which is a straight line where you get all the vital values which you could calculate in equation. You see here you are getting 1 upon Vmax, that is reciprocal of Vmax, so you can calculate the maximum velocity. Here you can calculate 1 upon Km, minus 1 upon Km, that means you can calculate the Km. So both these values are given by the equation also. Okay, and the best part is the slope. The slope gives you the value of Km upon Vmax, right? So this plot has an added advantage of getting a very accurate value of Km and Vmax when you compare this by the method of normal equation. So this is the advantage of LB plot, that experimentally when you want to calculate Vmax and Km with a great accuracy, you depend more upon LB plot as compared to MM equation, because in MM equation you can get only an approximate value, not a very accurate value. So reciprocating the MM equation increases the accuracy, and therefore it is realized now as an Lenoir-Burke plot. So I hope this module has helped you to understand what is LB plot, how it is related to Michaelis-Menten equation, and why it is essential to calculate LB plot if once we have derived the MM equation. Thank you.